Hello. Hello. Okay, so I'm doing this for the first time, so I don't know how this is going to go. Okay. Okay, let's see. I don't know if everything is visible. Am I visible? I have absolutely no idea about that. How do I do it? I don't know if I'm visible or not, to be honest. Let me see on my phone actually if I'm visible or not. Uh, hmm. Share privately. So what should I write here? Okay, email address. By the way, I don't want to share this. No. Cross. Yeah, now I'll try to share this to myself to see if I'm actually invisible or not. Okay. Notify via email is okay. Okay. Let's see if I'm visible or not. I haven't received an email though. Save video to share. No way. Nope, I'm not getting any. Okay, if I go on YouTube, let's say, and I'm on my. Well, this is unrated for me, so I don't really care. Where is my Gmail account? Okay, here's my Gmail account, right? Okay, so how do I share? I really want to see if I'm visible or not. Zero viewers, zero likes. That probably means that I'm most probably. That is okay there, I think. But okay. Okay, if I share the link, like if I copy and paste on my WhatsApp to myself, okay. But this I'm doing it for the first time, so I really don't know. I just want to confirm everything if it's fine. If it's fine. If it's fine. Oops. It's fine. Yeah, it shouldn't be an error, I think now. Okay, I've switched off my volume. Oh my god, I've got an ad already. That's amazing. At least my volume was okay, I think, right? My volume was okay. Okay, so I am live now. Okay, now I want to check if my screen is. No, let me share my screen myself. I'm just playing right now. Okay, let's do this. Okay, good. So I can see myself here. That is good. I can customize or not. This camera is very small at the bottom, right? Okay, anyway, I think this is okay, right? This seems to be okay. Okay, I have my Visual Studio Code open. Okay, my contest looks good. Right? Seems nice. Hello. Hello. Okay. My volume is a bit low. I need some kind of mic. I'll take my office headphones for this. I hope this works. This is all set up, guys. I mean, whom am I talking to? I'm just talking to myself right now. Okay, let's apply this. Let's put this on here. Okay. Now I'll test my volume again. Again. Hello, hello. Again. Hello, hello. Yeah, seems okay. Seems okay. Seems okay to me. I mean, let me just check what my mic is right now. I have to check what kind of mic am I using. Yes, the mic is on, but which mic I'm using is the question. I think this is okay, right? My face looks okay. Now let's see how my contest goes. I've set it as unrated because I don't want to take any stress. Okay. Let's try till. I mean, obviously, I don't expect D to be solved, but let's see how it goes. Okay. We are just here to solve problems. We are not here to see what we can do or not. Okay. Consider encross and grid filled with numbers as follows. The first row contains. I hope I am able. I'm visible. Yeah, I think I'm visible and looks good. Looks good. Let's see how it goes. Okay, from left to right. Okay. First row. Okay, 1, 2, 3. Okay. Second row n plus. Okay. Let's define cost of a cell as its value plus the sum of its neighboring cells' values. Two cells considered neighboring if they share a side from all the cells in the grid. Okay, so it's got to be somewhere over here, right? Uh, it's always going to be this cell, right? It's always going to be this cell. So you have n square plus n square minus 1 plus n square minus 2, right? And this is n square minus n minus 1, right? This seems to be right. Let's see. I mean, I can prove, but I don't really want to prove this is A. But I shouldn't think it that way always, right? This is not the right way to think. But anyway, I am just here to have fun and let's see how it goes. So I said n. Okay, first of all, n star n. So it's not going to be long, it's not needed. So n plus n minus 1 plus n minus 2, right? And we need plus n minus n minus 1. Is it always going to be like that? I just have to see the side cases though. So it's 4n square. It's 4n square, right? 4. Okay, I don't really want to do this. This is right. So let's see if it's. Okay, so for 1, we just have 1, right? Yeah, this is a side case. For 2, baki to sahi hoga, right? 5, for 5, what it is? Also, by the way, we can always create. We can always create a vector for this. There are two ways. It's math or vector, right? What is it gonna be? Let's create a vector. Why not? I'm not gonna think. v of I dot push back of start, right? And obviously we're going to increment that. Hmm? No, what am I doing? This is right, I think, yeah. So we are at ij, we need to see all the neighbors, right? Left, up, right, down. Zero, 1, 0, -1, right? So we're gonna see 4 directions. This shouldn't be a daily. Come on. Okay, so and x equals I plus dx of k. Similarly, y we have j plus dy of k. If x is greater than equals n, x less than 0, y greater than equals n, y less than 0. We're not going to see that, okay? Else we're going to see. So we're just going to continue in that case. Yeah, so we can just continue. And here we are going to sum the neighbors. I don't know what is the solution, like the correct solution, the intended solution, because I don't want to think about it because this is always going to pass, right? So v of I of x of y. And by the way, we are always going to have this, right? Yeah, this okay, ne is basically v of I of j. And we need to maximize that, right? Here mx equals max of mx comma ne, and we're just going to print. So this will pass, right? N square 4 times n square, that's it, right? This will pass and there shouldn't be any TLE. So much effort on A, right? So much effort on A. Okay. I took how much time? I took, I think, like 10 minutes, I think, right? Which is really bad. Which is really bad. Okay, let's go on B. Addition on a segment. I hope, by the way, I'll look again. Today is just basically try. I really want to see how it's going on. Oh my god, I'm looking so fat. This is not good. Okay. Okay. So addition on a segment. At least it's not so bad. You start with an integer array A which initially consists of n zeros. You have to perform the following action. And by the way, I hope that I'm not live, which would be really bad. Okay. Yeah, I'm not live, right? Yeah, I'm live, but this is private. No, it should be private. It's private. And yeah, I'm sharing it to myself. Everything is okay, right? Everything is okay. Oh, doing this after solving a problem which is really wrong. Okay. You start with an integer array A which initially consists of n zeros. You have to perform the following action exactly n times. Okay. What's the action? Choose two integers L and R and assign AI equals AI plus 1. Increment it by 1 for all I from L to R. Okay. So we are taking a subarray incrementing by 1 all the elements in that. You're given an array B consisting of an integers. You're tasked to choose values Such value is LNR for each action that after all n actions are performed. Okay, we have to do n actions, right? Okay. It's possible to reorder the elements in such a way that A becomes equal to B. The maximum value of R minus L plus 1 over all actions is as large as possible. What is the maximum value? Okay. So it says that we have to do n operations. I'll see that later. It asks us to choose such values L and R for each action that. And by the way, I just thought that is it possible to uh, do the editing later on? I don't know. It should be, but it doesn't matter because I'm just doing contest and we'll end it after the contest. But anyway, we'll see. We are doing this for the first time. A becomes equal to B. So here we can have, okay, we can reorder, right? So okay, so it's 3 here. It's 3 here, it's 1 here. But why 1 here should be 5 here, right? Because we can, oh, we have to do it n times. Okay. We have to do it n times. I see. One, two, three. Okay. This is crazy. 105, 134. Yeah, there has to be some kind of side case because this is, yeah, what is this? Um, so it says that 0, 1. Okay, let's say if I have, I'm just thinking this way 4443. Okay. So these all, so this will always, so I can do this. Yeah, this is easy, right? This I can do 3 times, and this I can do 1 time. So R minus L plus 1 is the length, is the maximum length is 4 in that case. Okay. But where's the problem? Let's say this is a case 1 2 3 4 1. Okay, we need to do 1. Oh, but again, this, yeah, because here 1 1 1 1. So basically we do, for this we'll do 1 to 4, and then we'll do, then we can just do it simply, right? This is simple. 1 2 3 4. Yeah, I mean, then I can just do like 1 3 1 2 3 3 4 4, right? This is working, and we have this length as maximum length. 1. Yeah, this is right. This is right. So where is the problem? Let's say if I do something like this. 1 2 3. Ah, the side case is just 1 1 1, right? Seems like that only. Okay. Yeah, this is, yeah, that's it, right? And I think the reason will be pigeonhole principle, right? And by the way, if we have zeros as well, this is also a case because zeros are allowed. Okay, what about this? We are going to have 1 always. Yeah, this is a side case. I didn't see that. Okay. So here, oh, but this is just not possible. This is just not possible. I hope this is always possible. Good. Let's do it to 1, 2, 3, 1. Yeah, this works. 1, 2, 3, 4. Let me think here actually. No, this is not possible. I need to do it. Yeah, oh. So the sum has to be greater than equals to n. That is for sure. So yeah, that is for sure. 1, 2, 3. Yeah, I get it. 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 Actually, what I can do is, okay, okay, okay. Yeah, so this is easy. This has to be easy. I can sort this and say if I have the lower bound where there's non-zero element till the end, this length, right? I need the sum first of all. If I decrease this length, like decrease the length from the sum, it should be greater than equals n minus 1. Then we are good. Okay, yeah, that is the question. I need the sum first of all, and I think sum can go to long run, right? I don't like that. Okay, n sum equals 0. Oh, I can do this accumulate function, right? Okay, here we are. So what do we do here? Um, if v of I is 0, I don't see this element. Now here I am concerned, right? So here I check if v of I, no. What do I check here? If n minus 1 minus I plus 1, right, which is n minus I essentially, is okay. So if I decrease this, if sm minus this is greater than equals n minus 1, then we're good. Then this is our length. Just want to write this n minus I, you know, and we're gonna break always. Yeah, this should be right now. Seems to be right. Yeah, I mean, we just have to tell the maximum length, right? So essentially what I'm trying to do is we will get the maximum length in first step itself. This is what I'm doing. See, we don't really need to do the whole simulation. That could be done, but we can only say that in the first step itself. And that is why I added the break statement here. We're always going to get the maximum length. Yeah, this should be okay. Let's go to C. Quotient and remainder. So you're given two integer arrays. Yeah, what was there was something, right? They said in the announcement. I want to see the announcement first. R of j equals x mod. That is, this is true. This is correct. That is, maybe this is something important to see in this problem. Okay, let's see what is the issue here. So you're given two integer arrays q1 and q. I'll see myself again. How do I look? Um, it's funny. Yeah, I'm looking handsome now. I was looking fat, but now I'm looking handsome. No. Okay. Uh, so we are on C. By the way, I have LinkedIn on. Why do I have LinkedIn on? You're given two integer arrays, this, and as well as integer k. You can perform the following operation any number of times. Choose two integers x and y such that x is greater than y less than equals k any number of times. Okay. Operation, and these two we have to do. I think we have to do, right? Integer I such that q equals x by y rounded down. Integer j such that rj equals x mod y. My mom's texting me. Call at 10 p.m. Giving contest. Okay, let's do this. Focus on this. So we have to choose two integers x and y such that okay. Remove qi from the. This is a complex problem to read now. This is a complex problem to read. I would like to see D first. Okay, this is DP for sure. I'm telling you, this is DP. Yeah, this is DP. And I know, I've seen this problems, exactly similar problem in one of the contests long time back. I also saw Omnic stream and he solved that problem using DP. Just by looking at the face, I am saying it's DP, but this is really wrong to say that way. This is basically underestimating the problem, nothing else. No, okay, I'll solve C first and we'll see D later on. So choose two integers x and y such that, okay. So we're going to choose x and y, okay. I such that this is rounded down. Okay, we have our freedom to choose anything. Okay, q equals x by y. Okay, there has to exist an integer I, and rj. Okay, there has to be an index j such that this is true. Okay, remove qi from the array q and rj from the array r. Anyone can remove. Okay, Mahasana, okay. So this is the question. We have the freedom, but that freedom is limited to at most k. Okay, okay. This is the freedom that we have, and k is huge. By the way, we know that, yeah, the announcement said that this x mod y will always be less than y, right? It'll be from 0 to less than x mod y. This is for sure. Can we say any relation that we have between rj and qi? Can we say if there is any relation? If there is, then we can simultaneously remove them from the two arrays, right? I'm a little afraid if live and anyone is seeing me? No. Okay. Yeah, I have made it private, so no one's going to see me. What am I thinking? Okay. Maximum number of operations that you can perform on the given arrays Q and R. Hmm. So we have N and K, we have Q array, we have R array, Q array, R array. Wow. Okay. But the problem is, there could be for a particular, yeah, I'm getting what it is. So for a particular QI, there could be multiple RJs. I have to select the optimal one in order to continue the operations. And we have to tell the maximum number of operations. This is what has been asked in this problem. So what is that optimal QI and RJ, right? Hmm. Okay. A very, very bad test cases that they've given. That is why the problem is hard, right? That is why the problem is going to be hard. That is why the problem is going to be hard, right? Yeah, see, look. Yeah, the submissions are okay. Submissions are okay. But what I can judge from this solution like this is that the test cases, I mean, the solution is direct just by looking at the submission percentage, like the correct submission percentage. Or probably I can say that the third cases is too strong, right? So maybe that I underestimated the test cases. Anyway, let's come back to problem and think about it. Okay. Man, if even GM has, although I shouldn't think it that way again, OD is difficult. E is easier. Oh my god, E is easier. What is E? Yeah, I knew that. Okay. Okay, E is easier. Is it a greedy or something? Because in Div 2s, they are starting to ask greedies in even E. I think I should solve C and then we are gonna not in the mood to solve ahead. Because this is already a challenging task, I think. Uh, okay, let's think about this one. Okay. By the way, this is remainder, right? And remainders, this we are never gonna touch because k is this much only, right? So in order to increase my remainder, what is the maximum remainder that I can achieve? Is the real question now. Yeah, what is the maximum remainder I can achieve? What is the maximum remainder? Okay, so this is a math problem. Okay, so we have 1 less than equals x less than y. No, y less than x less than equals n. This is what we are given, right? Close this. Yeah, yeah. I just did it full screen. Now, am I able to see myself? Oh, wow, that is amazing. Okay. So, you know why I am doing this? Because on YouTube, if I, what do I say that? If I stream on YouTube, or basically I'm saving my storage on a Mac, like on my personal PC. So that way, okay. So this is right now. I'm interested in this question. I really want to solve it now. Okay, so we are given this. So I want range of remainders is what I need. So remainders, oh, that is the question. and the range of remainders is to range of questions. But for a particular question, what are the range for remainders is the real question. And then we basically solve the problem, right? We basically solve the problem. That's it. So we need three things: range of remainders. Yeah, this is basically the crux of the problem. Range of quotients, and third is for a quotient. My maths is not strong. That's why I'm a noob. What is the range of remainders? So once we get these three pointers, we are done with this problem. So let's solve it one by one. So what is the range for remainder? Okay. So range for remainder is going to be, obviously it has to start from zero for any case, or not for any case, because it's possible. But that is a what is the constraint for case two, right? Also, they're basically saying that yes, it will start from zero. So remainders, I am saying R, okay. So it starts from zero always because of the constant. I mean, it has to. And till where do they go? So x mod y is what we are doing. Okay. So let's say we have k some value, right? I want to take some value. Let's say if I'm taking 42, okay? And I am obviously dividing it by what? I can divide it by 22. I don't know how I'm gonna get. Okay, what if I do it by 41? No, I'm gonna get one in that case. For this, I'm gonna get two. So like that, if I go to 22, how much do I get? I get 20, right? For 23, I hope I'm doing it right. I want to use my Python term in my terminal. Let me see. So Python, I'm going to use. So print 42 mod 20. Let's see. Oh, sorry. What am I doing? This has to be, yeah, 41, 40. Okay, this goes till, let's say, 22. Okay. So the range of remainders k to k by 2 plus 1. Okay. So range of remainders is, what is it? We're going till 20, right? By the way, 41 by 20, what is 41 by 20? That is a little bigger, no? Oh, sorry. Oh, so maximum is 20 that we can get. Are you for sure? Like, we can't get 21 at all. Hmm. So, n minus 1 by 2, k minus 1 by 2. This is right. And obviously, this has to be integer division. Makes sense, no? For 40, it is to be. I'm noob at math, so I'm struggling again, which is really sad, right? 19. Yeah, seems to be right. Equals to sign, right? Yeah, we have this now. Now range of quotients. Do I need that? Wait, if I can remove one of the pointers, if I have the range of remainders, and for a particular remainder, I have. Oh, but the problem is, here also there is a problem. Which remainder out of that range to be selected? This is another problem, right? Yeah, this is what I thought in the start. Let's do this opposite way. For a remainder, what is the range of quotients? Okay. So let's say if I have a remainder, that's cool. I have a remainder. Oh, but the maximum remainder that we can get, what is the max? Okay. So let's take our max. How can I obtain? So 42 mod 22 is one way, which gave me what? 21 or 20. It was 20, right? Hmm. We can also get that by 41 mod 21. Only two remainders I'm getting. Okay. Right. And that's it. We are done. We are done basically. With these two, only these two remainders I can get. I mean, these are the two ways that I can get the remainder. Now, so this is 142 by 22. What is this? I'll use a terminal. Why not? Print 42, and obviously it has to be integer division, right? They mentioned it. I'm getting 140. Okay, this is obviously one. Yeah, always gonna be one for R max. Okay. So now let's change the remainder now. Okay. Let's do for 2. So y has to be at least 3. Ah, makes sense. Makes sense. No, no, no. Let's not do it for 2 then. Let's do it for 3. Okay. Let's do for r equals, what is the remainder? We need 19. We need r 19. Here we needed 20. Okay. Now we need 19. So obviously our y has to be greater than equals 20. Okay. Hmm. Now 39 mod 20 seems to be right. 40 mod, wait, yeah, 40 mod 21 seems to be right. Oh, we have now three. Oh, okay, we have 3 questions, right? 41 mod 22 seems to be right. And 42 mod 23 is also right. Oh man, this is so tiring, man. Okay, so 1, 2, 3, 4, and here we just got 2, right? Which is really fascinating. Why did we get 2? What is the R max here? It's 20, nah? So, okay, so yeah, this is right. 21, 22. Good. For 19, we are going to start from 20. So 20, 21, 22, 23. We're going to start from 21. 1, 2. Wow. How is this right? Wait, I just can't believe it. 1, 2, 3, 4. 1, 2. No, no, no. Wait. Hold up. Wait. So we have. Let's start from the smallest one. So that means y has to be at most 21, at least 21. So that means uh, hmm, 20 we need. So 41. Oh, so what I was 41 mod 21 it was, right? Also, I was doing right. 41 mod 21, 42 mod 22. Can we get 21 by any chance? No, we cannot. We cannot. Right? We just cannot. 21. We need at least 22, and yeah, we're just not getting it. Just not getting it. Yeah, seems to be right. So it's multiplying by two the range for questions for a particular remainder. Okay. So let's think about r equals 18 now. So y should be at least 19. So let's think about uh, oh into 2 minus 1. Okay. So it's always going to be multiplied by 2. I see now. Okay. Now my math is coming into picture. Okay. So basically what is happening is we are decrementing y by 1. So we're getting two extra quotients for a particular remainder. Why? Because if there is a remainder that is, let's say, some r, if we need r, so this y multiplied by 2 minus 1 has to be the dividend, the number by which we'll be taking the modulo with. Only then we are going to get the maximum that particular remainder, right? I hope I'm saying this right. 13, yeah, this should be right. This should be right. This should be right. So we can, okay, so I can go from the maximum remainder, and which one should I remove? Which question should I remove? Oh, by the way, how many questions do I have here? These all are one. Wait, these all are. Oh, this is one. This is one. This is one. This is one. One, one. What? So all are one. Okay, so y greater than equals 19. No, there has to be some. Oh, there has to be some quotient. I'm sorry. Yeah, there has to be some quotient. Okay, so for. I'm getting it. I'm getting it. I'm getting it. I'm getting it. So if the quotient is the least, we should remove the biggest remainders. This is a greedy approach that I'm thinking right now. And this is really bad. The time I'm taking to solve this problem is too much. This shouldn't be the. And by the way, why am I? I hope I'm not. No, 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 no. This should not happen. I hope I'm unrated for this. I hope I'm unrated for this. Please. Why there is no star over here? Because I'm unrated. Why? No, I selected for unrated. Why is this rated for me? No clue. I think I selected for unrated. I don't know why it's showing rated for me. Doesn't make any sense. So there has to be some. Okay, so for maximum remainders, I mean for minimum quotient, we are going to take out maximum remainders. Okay, that is a greedy approach. So decreasing, increasing. Okay, for one. Okay, by the way, which one is remainder, which one is quotient? Quotient and remainder. Okay. So the greedy approach that I thought was to take the maximum remainders for smallest quotients. Hmm. So by the way, 100 is not possible. That is for sure. 9. For 9, now we'll be taking. Yeah, this is what we have to do. This is what we have to do. Yeah, this is what we have to do. Because later on, it is only going to increase. है ना? Let me think about this. Let me think about this. Yeah, this should be right. The approach that I just thought. So we have quotients, remainders. I think this is the order, right? Okay, we have this order. Okay. I really wanna edit the video because I don't know. Uh, because I'm actually wasting a lot of time. But this is natural, and I think that serves the purpose, right? Okay. So I have Q and R. Hmm. So I sort on the basis of remainders first. And this has to be decreasing, and my knees are paining right now. I need a laptop table as soon as possible. Okay, so I have R and Q. Now, largest remainder for smallest quotient. Man, I'm gonna end this stream after solving this question. I'm just too tired right now. Uh, okay. So largest remain. Okay, so let's try to simulate this. If this works, if my simulation works for this, I don't care. My solution is correct. Man, I'm so nerdy right now. Uh, so these are my questions, and this has to be increasing. This has to be decreasing. Sorry, and this has to be increasing. So 8899, right? Now this is just not possible because k is 42, right? K is 42. Keep my legs like this. Yep. K is 42. So we are just not, it's just not possible to get 100. We can at most get it as k minus 1 integer division by 2. As as right. This is what we can get. So here 20 will be the maximum remainder. So this is too stupid. Now we are at 9. I'll try to remove 1 from for this. Okay, this is my approach. So remainder is 9, quotient is 1. Is it possible? So for remainder 9 and quotient 1, what we need is y to be at least 10, right? So if y is 10, let's say y is 10, right? Yeah, this is the best thing to keep, the smallest one. Then x will be less than equals 19, right? And obviously x is 19 for my r to be 9, right? Okay. Okay. So I can remove 1 for this. Very good. Very good. I can go ahead with this. Oh, but the problem is I should. Oh man, this is a little tricky now. I've got the crux now. Although I've got the crux. Now, okay, so let's say I remove these two. I'll just do this. These two are removed. And this is impossible to get. I'm just doing this. Okay. Now, r equals 9, q equals 2. Let's see if it's possible. So, r equals 9. That means y should be at least 10. And obviously, I'm going to keep y as 10 always because I need to keep it as minimum as possible, right? Hmm? Because if I increment that by 1, then I have to increment x by 2. Is it the case? No, it's not the case. Sorry, it's not the case. But that does that make sense? That never makes sense. No, that never makes sense because I need to keep my x minimum. So that's why x will be 28. No, it will be 29. 29. Increment by 10. Yeah. No, I'm thinking it the right way now. I'm pretty sure I'm thinking it the right way. So we can remove this and this, right? Because x is 29 and we are good. We are in that freedom limit that we have as case 42, right? I want to see if I'm looking good or not. I'm sorry. I'm so close to solving this problem, but even though I just want to look at myself. Stupid me. Nah, my face is not visible. Oh my god, okay. Yeah, my face was not. That's why, man. That's why. Look at yourself. Just look at yourself. What you're doing, man. Yeah, I should buy a laptop stand later on. I don't have laptop stand. Okay, so we have r equals now what? We have 8. Okay, so let's go with 8. So what to keep q? Quotient is 2 again, right? So y has to be 9. Yeah, I am doing it perfectly correct now. This is a greedy approach and this has to be correct. 17, okay? And then I increment by 999. That is what. Yeah, this is what we have to do. Yeah, this is done. Now this problem is done, I think. But I just have to simulate it once to confirm. Okay, so this is removed. Let's do it quickly now. Come on, Arnav. Remove this. Now we are at 8. R equals 8. Q equals 4. Y has to be 9. So X is going to be what? Come on, Arnav. 17. Wait. Uh, plus 8, something like that, right? 8, 33. Something like that, okay? No, this is wrong. What am I doing? Plus 9, 35. But this is plus 9. Yeah, plus 9, 9. Wait. So this is a 1. This is I need for 2, so it's going to be 26. 35, 44. Oh, this is not possible. So we are ending up at 3, and this is the right answer. This is the right answer, right? Now we just have to code it up. And max remainder possible. By maths, I am saying this has to be minus 1 by 2. But my maths is not strong, so please don't judge me on that. So now for a particular remainder, yeah, I start from the least remainder, right? Yeah, I start from the least remainder. No, I start from the max remainder, right? Huh? I start from the max remainder. So my remainder was how? I didn't. Okay. Oh yeah, here it is. This is my quotients. This is my remainder. If r of I is greater than equals greater than max, we just want to continue. This is stupid, right? Now, if there is some remainder that we got, we'll select y as what? As our r of I plus 1. We need the quotient to be q dot back, right? Huh? It has to be q dot. No, but oh, sorry. No, but then if it's wait, if it's this can go off n square. What is the complexity? No, it should not go off n square, but it may go off n square, and I have to keep it this. Oh my god! After a long time. Okay. No, you'll always get it from the back. You'll always get it from the back. I'm 100% sure. If you don't get it, if you don't get it, no, 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 wait. So if you, okay, calm down, okay. So if you have a remainder, right? If you have a remainder, and for some reason you're not getting the quotient, but for a smaller remainder, you may get the quotient. Is this the right statement to give? That's definitely a right statement to give. For the This is the right statement to give. Hush, this is right. Why am I thinking so much, man? Why am I thinking so much? Oh, why am I thinking so much? Okay. So int q equals no. I'm just not capital Q equals q dot back. Right. To get that particular q and that remainder, this is remainder, right? Huh? No. This r is r of I. I'll do it simply way. Okay. Y equals r plus 1. Hmm. Now, what's the time? Oh my god, this has taken a long time. This shouldn't have taken a long time, but I'm just, too tired right now. Just came from the gym. Okay. So we need that remainder. So the first remainder that we can get. Oh, what? Just do it by y plus r, obviously. Oh my god, okay. Oh my god. Oh my god, wait. This was so easy then. No, I'm doing it right though, but this is what is happening. Oh, this is just Euclid's division lemma, man. Right? I don't know. If x, if we are under this freedom, we can remove this q, right? Oh my goodness. And your answer will be plus plus. Yeah, that's it. And we just going to print the answer, right? How stupid was this question? I'm getting 4 here for some reason. Okay, why am I getting a 4 here? Okay, I'll see the indices where I'm incrementing the answer, okay? See how I I I have my Q or this should be good to see. Let's see how, and also I'll this is just for my sake. So we are removing from 0. Good, this has to be 1. For here, I'm removing 1. Why am I removing 1? I have to see that. So I equals, at I equals 0, I'm removing, okay? So we are here, we are going till, this is obviously sorted, so I'll go till 1. And this has to be 665. Smallest quotient. Yeah, this should be right, huh? So, 5, oh my god, I should actually write this. Yeah, if this is done, I think, yeah, this should be the right solution. Come on. I just want to go to eat now. This is so stupid. So this is my quotient, right? So this will become 655, right? No, this, my remainder becomes, no, this is right. And quotients, yeah, and my remainder becomes 177. Now I'm going to 1. And what's my k here? 10. So these two are just simply not possible. This might be possible. And this 5 I'm not getting. I mean, I'm getting according to them. How am I getting this? Quotient is, okay, R is 1. So I'm taking, okay, R should not be possible to be 0, right? If it is, good, 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 good. So I'm taking my Y as, I think this is right now. Y equals R plus 1, which is 2. This is 2 plus, no, 2 plus R is 1 times, what is my Q? Q dot back, which is 5. Comes out to be 7x. So x mod y is coming out to be 1, which is wrong, which is wrong, which is wrong. Why is it wrong? Oh my days, oh my days, oh my days, oh my days. No, which is right, because my remainder is 1. So this is right. I can remove this. Hey, I can remove this actually, right? I can remove this. So round it down. I forgot that quotient. Oh, but oh, 7 by 2 is, oh. No, 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 no. Wait. Wait. So quotient to be 5. Quotient to, Oh my god, this is just Euclid's division lemma. So quotient to be 5. I'm dividing it by 2, that I have to take care of. है ना? Wait, this is Euclid. R is my 1. Q is 5. Oh man. Oh my god. Oh my god. I should go back to class 10th for this. A equals BQ plus R. Okay. I remember this. A equals PQ plus R. Okay, so my R is 1. Q is 5. है ना? So here I can actually what? I can keep this as X. This is my Y. This is my R. Oh my god. No, this is not my Y. This is not my Y. This has to be my Y. So now, according to my math, so-called math, it should be. Oh my god, this has to be Q here. Are you kidding me? That was it. Oh my god. Oh my god. Stupid me. I hate maths. That's why I hate maths. Yeah, this is gonna work according to my greedy shit that I just did. Oh my goodness. What did I just do? What did I just do, man? Oh my god. Now this obviously is correct, but very poor execution. Oh, my poor execution, man. Look how much time I took. 50 minutes. Oh, I'm very disappointed by myself. I started my contest half an hour late. Or should I say 20 minutes late. Mhm. This was not it. This was not right. But anyway, I was able to complete this problem. I'm happy about that. So what was the crux? The crux was that maximum event possible is this. I just saw that by observation. I don't have the proof of that. So you can't have this, obviously. And yeah, this is also an observation. So this was greedy. This was the greedy that I had to do. Sort this in increasing, the remainder sort this by decreasing. Ah, okay. It was a fun contest though. D list problems, right? List solves. What could be the problem? Is it that D is wrong? Although I'm not gonna solve it. But Wow. And by the way, oh my god, why have this all? And this guy all no, this guy is smart. I know this guy's stage is smart. Um. Okay. Well, they took time in C, which is surely because of an observation. But I don't know why. I took around what happened. I took about I think 10 minutes because of 10-15 minutes because of my poor execution of that Euclid's division lemma. And where did I lack? I'm gonna see where did I lack. This was the major thing. Where did I lack though? I didn't lack anywhere. Yeah, this was very slow. This was super slow. Yeah, this was just basically this thing that I was doing. This was very slow. This is what happens because when you have weak maths. Okay, anyway, this was a good contest. After a long time, I'm giving. Not so long because I just gave Meta Hacker Cup as well, but not so bad, not so bad. But I should have solved this within an hour. This should have been solved. If not within an hour, at most, I think at around 1 hour, right? This should have been solved. Looking at other people as well. I mean, this guy's super strong. He should have solved it even better, even earlier. But well, it was difficult for even good people. Then maybe I'm not so bad. And obviously, these solves, I'm just not in the mood to solve under 1,000 submissions. And even D is difficult, so obviously, no chance. So I think, yeah, this was basically speed forces for sure. This contest for speed forces. If someone solves quicker, then their rating shoots up very quickly. So this was speed forces for sure. ABC. You have to solve quickly ABC. A and B were simple. A was brute force. B was yeah. This is my feedback. So A was brute force. I mean, there could have been a better solution for sure. It is maths, right? But I don't like maths, so I just did a brute force, and obviously the constraints were okay. For B, it was that you just had to select. I mean, you're going to get the maximum length on the first step itself. So that is what this was. So this was obviously off and solution. Off and login because I sorted it. Yeah, this was in login. And yeah, and C was Euclid's division lemma. But I should have solved it quicker. But well, it's life. Okay, thanks for being here. If you made till here, I don't know if I'll do it later on the streams. This is something for the first time I'm doing, so let's see how it goes. And yep, until then, bye bye.